Okay, exploit symmetries to find more identities and solve other similar problems. Okie dokie, so I've got my unit circle up here. Previously we've already done what happens if I go with positive angles versus negative angles. We've done what happens if I go backwards from pi, forwards from pi, but we haven't done starting on the vertical. So that's what we're dealing with, pi on 2 minus some angle and pi on 2 plus some angle. The way that I'm going to teach this is going to be with thetas in the acutes, but it does generalise nicely to the rest of it, and I'd highly recommend that you have a think about that and convince yourself and make sure that you're happy that it does actually work for any theta. I find the best way to convince yourself of that is to go through each quadrant and just make sure it works around nicely and okay. You can get away with just doing 2 quadrants and then generalise out, but it's not necessarily straightforward, so it's up to you. Okay, so I've got my unit circle, everything's nicely labelled. Okay, well, let's think about this for a second. I've got pi on 2 minus theta, so I'm pi on 2 minus theta, that pink is the theta, so I'm going to come down to there. Okay, great. If I was talking about sine of this thing, that would be the blue line, and if I was talking about cos of this thing, it would be the green line there. Okay, well, how else could we think about this? Well, whatever pi on 2 minus theta is, it's going to be this purple amount. Well, we can exploit that and say, well, what if I just came up here by that purple amount? Alright, well then this angle in here, that would be back to this pink theta again. Okay, well, I've got my blue here, so if I flip that over here, my blue would become up there. Okay, well, the blue of this thing is the cos of this pink. Because I'm coming up, right, I've got that side, that's now cos because that's now the horizontal. So originally my blue, being sine, has become the cos of just this angle. So I've got sine of this becomes cos of just that angle. Similar story, I've got the green, okay, that flips to become the vertical sine. So sine of the pink equals cos of this is sine of the pink. Alright. We can go through similar arguments for the other side as well. I'm going to leave that to you to think through to make sure you're happy. If you get stuck on anything, obviously just send us an email. But there's a huge chunk of them. Some of those we've already touched on before, but that's a more or less complete listing of the ones that you can be bothered with. For the most part, you won't even need the 3 on 2s, but just in case you'd like them, they're in there. So that's that. Other ones to notice, which I can't remember for the life of me now because I've done it so many times, whether or not we've done this year or not. So sine squared plus cos squared equals 1. Hopefully that's a bit self-evident rather, because if we draw a unit, well, just imagine that that's top right quadrant of the unit circle. There's some angle, regardless of what that is. There's my cos. There's my sine of that. Well, this is a right angle triangle, so this squared plus this squared must be that squared. Well, this is 1 because it's a unit circle, so sine squared times cos squared, sine squared plus cos squared must equal 1. Bang, done. And we have definitely done this already, sine divided by cos, tan. So that's a largely complete set of trig identities, save for double angles and anything calculus-wise. So that's handy. Okay, let's see if we can't apply some of this stuff. Sine of alpha is 0.1. I want to know what sine of pi minus alpha is. Okay, well for this we can just go across to the identities, which is this one in this case. Yes. Cool. Well, it turns out that's just equal to itself. So that's equal to sine of alpha. Well, we already know what that is. That's 0.1. Nice and easy and boring. Okay, cos of 2 pi minus beta. Okay, well, hang on. We don't have 2 pi in here. How are we going to do that? Well, just remember, hang on, 2 pi, I've already gone around the circle. So this is equivalent to just being cos of minus beta. Because if I went 2 pi then minus beta, all I've done is minus beta. Okay, great. Cool, alright, well, cos negative beta. Alright, now we can use our tables or our intuition, depending on which way you want to go. That's the same as the positive version. Cool, well, we know what that is. Beautiful. Alright, sine of pi minus beta. Oh, this is a little bit more fiddly now because we don't know what sine of beta is. Okay, well, do we have a way of combining these? If we look through our table, no, all the sines go to sines, all the cos go to cos when you're around pi. How else might we be able to do this? Well, if we think about it for a second, we might say, oh, hang on, if I take cos of pi minus beta, cos of pi minus beta is this guy, would be negative cos. Okay, so that must be negative 0.2. Alright, well I know that this thing squared, we're going to do this, yes. I know that cos of the thing that I'm interested in, so I'm just going to call that b now instead. This thing squared plus sine squared of the thing that I'm interested in has to equal 1. I know that this is negative 0.2. Okay, did we ever stipulate? No, so we can get two answers for this. What do we get? 0.04 plus the thing that we're actually interested in, so I'm now just going to call that my answer that I'm interested in, squared, equals 1. Therefore the answer must be root, what's this, 0.96, which I think will simplify, but we'll leave it like that for now. Cool, so I've got this. Alright, can I do anything with that? Well, I've got a slight problem with the plus minus, but that's it, that's all I can do. Because I don't know necessarily what quadrants it's in, since I don't have any boundary on beta, I should say. So that's that. Yep, that's all I've got. So positive or negative root 0.96. If we knew, for example, let's just say beta is between 0 and, let's say, pi. Right, well, it has to be pi and 2 since this is positive. That's fine. Cool, well in that case, alright, between 0 and pi on 2 is sign positive or negative. Well, it's always positive, so then we'd be able to get rid of that negative. Beautiful. Cos of alpha, alright, similar story. I know what, I don't have a conversion between these unless I know that alpha's between 0 and pi on 2. Since I don't, alright, we'll go this thing squared, so 0.1 squared, plus the thing that I'm actually interested in, squared, must be 1. Therefore, we have our answer is positive or negative root 0.99. Done. So sometimes they'll work out nice, sometimes they work out not so nice, but that's okay. Okie dokie. Other things that you might get, things like this, where you're only given one and you want to find the other two. Well, let's think about what this represents. I'm going to draw in a triangle because that's what all trig functions can represent. This is not theta, this is x. So x is some angle. Okay, great. I could type this into a calculator and get some terrible number. So, sine inverse of, what was it, 3 on 5. And it gives me 0.6435. So, 0.6435 ... and that's all it gives me. There's a problem with that, and we'll come to it very shortly. Okay, this guy gives me sine is O over A, over H rather. Oof. Gives me that. Okay, well I could use Pythag to figure out this last side, and because they're nice famous numbers, hopefully you'll figure out that that's a 4 very quickly. Okay, great. So that's one way that I could get there, and that's totally valid and fine. Well, we could say, alright, based on that, move this x down. Okay, well based on that, cos of x, well that's a on h, so this should equal 4 on 5. Cos of x equals 4 on 5, so that's done. And similarly tan is 3 on 4. Yep, beautiful. Now that's all well and good. Now there's a slight problem with this x if we ever wanted to solve that, so let's just put x equals question mark. Okay. Are there other potential solutions for that? Well, all we know is that sine was this. But remember, there's two places where sine can be positive. So this wasn't the only triangle we could have drawn. We could have drawn it that way to be in the second quadrant as well. where all of this outside would have been x. Okay, well that just means that this guy is now, whatever he is, negative 4, this is 3, this is 5, yes. What do we call it? I'll call that theta just to keep things a bit easier to distinguish. It's pi minus x in there. Beautiful. Okay, well now if I do cos of this, I get a over h, so this could be negative 4 on 5. And this could be negative 3 on 4. Well that's irritating. Do I have to do that every time? Well, short answer is no. You can be a little bit more creative. Or a little less creative. So you can either draw it the triangle way and then just think about, hang on, is there more than one solution? Or you can go, okay, sine squared plus cos squared has to equal 1. So 3 on 5 squared plus answer, we'll call it, squared has to equal 1. Therefore my answer has to equal positive and negative root 1 minus this, whatever that is. So what are we on, 25? 25 minus 9 gives me 16 on 25, gives me plus minus 4 on 5. Cool, which is what we ended up with there. And similar story for tan. You can do other more complicated things at this point, but the easiest way is just sine divided by cos. You've got 3/5 divided by either positive 4/5 or negative 4/5. So our answer for this bit is, which way around was it? 3/5 divided by positive or negative 4/5. Cool, 5s will cancel. I've still got my positive negative, 3 on 4. So I end up with the same results either way. Cool. This isn't overly critical right now, but it's fun to think about and just make sure your thinking is good. It's a very good set of practice to try to catch yourself making errors and try to improve your intuition slightly. But other than that, that's 14K. Email me if you get stuck. Cheerio!